Cool guys. So the next question is majority element. So let us start with reading the question first. Given an array nums of size n, return the majority element. Okay, an array of size n will be given to us. We need to return the majority element. Now what is this majority element? Majority element is the element that appears more than n by 2 times. You may assume that majority element always exists in the array. So an element is said to be majority element if it is present for more than, strictly greater than floor of n by 2 times, and it is said that always there will be an element, whatever the input array that will be given to us, whatever the test cases that are designed over there, always there will be a majority element. That means one element will be present for more than 50% of the time. So more than n by 2 times means that it should be present for more than 50% of the time. Majority element is not the element that is present for the most number of time. It is the element that is present for more than 50% of the time. The difference, I think you can get it, as over here it is said that in all the given input arrays there would be a majority element, so there will be one element that will be taken more than 50%. So it will be, you can also say that it will be the element that is occurring for the most time also. But the criteria is different. You should be aware of this, because there is a majority to element 2 as well. There also you need to follow up this question, right? So if I tell you, if I look at these inputs only, say this is an array of size 3. Floor of n by 2 is 1. 3 by 2 is 1.5. Floor of that is 1. So if an element is present for more than one time, that is, it is present for at least 2 times, then it should be called as majority element. See, 3 is present for more than once, so it is the majority element. Over here the size of the array is 7. Over here 7 by 2 is 3.5. Floor of that is 3. So if an element is present for 4 times, that will be considered as majority element. 2 is that element. So what I am saying is that, guys, if there is an array of size 7 for example, there can be 2 possibilities. That suppose I am considering 3 as the majority element, so there should be 4 3s for sure, and the rest of the 3 numbers, I am saying that there can be 2 possibilities. These 3 numbers can be filled with different numbers. For example, 4 can be there, 6 can be there, 5 can be there, or there can be one single number only. Suppose 4 is there. It should not be present for more than 3, but obviously there can be 2 scenarios where this 3, which is the majority element, can be challenged by many candidates, or this is challenged by only a single candidate. Obviously guys, in both the cases my majority element will be present for more time. What I am saying is, the simple most approach that is coming to your mind is obviously take a hash map, and that hash map should contain the element as well as its frequency. Element and frequency, right? Not elements. So this is the way I should store. So if I am iterating through this array, first 3 comes, the frequencies become 1, then another 3 comes, the frequency become 2, then 3, and then 4. After that 4 comes with a frequency of 1, then 6 come with a frequency of 1, then a 5 come with a frequency of 1. And then after the end of the iteration, I can iterate through this hash map and check if for a particular frequency, if for a particular element its corresponding frequency is greater than n by 2. If that is the condition, I can return that particular element then and there. Also what I can do is, during when I am filling the array up, suppose the array is something like 4 3 3 6 3 5 3, suppose the array is something like this, and maybe I am just changing the last 2 so that I can make you understand that before I travel to the last element I can also return the array. So what can I do is, I will make the same hash map, but this time after every iteration I will check if that element that I put right now, if that frequency is greater than n by 2. If that is so, then we can return from there. What I am saying is, if I am iterating through this array, 4 becomes once, then 3 comes once, then 3 comes 2. At every iteration, as soon as the frequency of 3 became 2, we check if this 2 is greater than 7 by 2 or not, which is n by 2, the size of the array is 7, right? So if this value is greater than 7 by 2, we return that value then and there. But obviously 2 is not greater than 7 by 2, so we continue. Then comes a 6 with a frequency of 1, then the value of the frequency of 3 gets changed to 3. Now I check again, is 3 greater than 7 by 2? The answer is still no. Then again a 3 comes, this time the frequency value becomes 4, and then we check is 4 greater than 7. The answer is yes. So then and there we return. We don't even need to travel to the last index. So this is one way of doing it. Obviously we are doing it in order of n time. We are doing it in order of n time, but we are also taking order of n space complexity, right? So obviously the number of entries, the number of key value pairs will be much less than the size of the array, but because there is a majority element which will occupy 50% of the array, but still it will be in order of n only. So this is my order of n time and order of n space solution. What I can do is I can optimize this to be done in order of n time only, but I can use only order of 1 space. That is, I will not use any extra space, any extra linear space. Okay. So basically, in order to do that, guys, there is a very clever approach which we follow over here. The approach is very smart. So what we do is, I am telling that suppose there can be two cases, as I have said, if the size of the array is 7 and suppose my majority element is 3, so 3 must be present 4 times, and there can be two cases, either the numbers can be same or the numbers can be different, right? So if I ask you which among this is more dangerous for 3, I would say that this is more dangerous because there is clearly a number that is challenging the existence of challenging the majority nature of 3, but over here there is no one who is close enough to 3. So this is a little bit more tough. So if I can devise a strategy that will also handle this case, then I can tell that okay, I have devised a strategy. Here we are kind of doing a token mechanism where instead of storing the exact count of 3, I am saying that the majority element is present for more than 50% of the time. So if I just keep a count of a variable and the candidate, if I have two variables, candidate and count, initially what I do is, in the candidate I take the first element. Suppose I take 4 as the candidate and I set the count to 1, and then what I say is that if I come across another 4, then I will increment the count. If I come across any other element which is not assigned to candidate, then I decrement the count. Then what will happen is, if 3, which is the majority element, is the candidate, it will until the end remain as the candidate, its count will never go to 0. But if any other element is selected as candidate, then what we will do is, if its count, if we find a different element and the count goes to 0, then if the count is 0, we assign it with the new element that will be coming in next, because this 4's count has been decremented and other elements are present more times. So that is why in that condition only its count will go down to 0. I hope this is clear. Just look at it once and in the second iteration I hope it will be clear. What I am saying is, I will take the first element as the candidate and assign the count to 1. Then there is another 4. So as soon as I see that okay, this 4 over here, it is equal to my the value that is assigned to candidate. For this 4 I am talking about, I will increment the count to 2. Then comes this 4, again the value matches with the value in candidate, so we increment the count. Then comes a 3, guys. As soon as this 3 comes, we see that the element and candidate which is present in candidate is not matching with this element. So this particular element is kind of resisting the majority nature of whatever is stored in candidate. So what I do is, I found a different element, so I will not cast a vote to candidate, I will decrement the count. Okay. Then comes the next 3, I decrement the count. Then comes the next 3, I decrement the count. Then as soon as the next 3 comes, it will, before checking the if it is equal to candidate or not, it will, all these variables, it will first check if the count is 0 or not. If the count is 0, it will first set the candidate to itself, whatever the value is now, and it will also set the count to 1, and it will not be doing any other operation like if count is equal to candidate, that we will not do, that step we will skip. So whenever the count is 0, we will reassign the candidate, and what I am saying is, by end of this iteration, the candidate variable will store our majority element. That is what I am saying. Why? Because if there are 3 4s, and that also I am placing it at starting, if there are, obviously the majority element at the end will take over this count of 4s and it will bring it down to 0, and then also there will be one extra element that will be left over in order to set the count for 1, in order to set the candidate to that particular element and also set its count to 1. There will be one extra element always. if this case, if we consider this second case over here, it will be easy for 3 to come up as the winner, right? Because first the candidate will be 4 and the count will be 1, because initially my candidate and count both I am assigning it as 0, for example. Both I am assigning it as 0, for example, in the starting. Now obviously as soon as the first element comes over here, it will see that okay, count is 0, so it will assign the candidate to itself and assign the count to 1. Next it will go to the, as soon as this is done, it will go to the next iteration. Then it will check if count is 0, no, count is not 0. Is the candidate equal to this number? The answer is no. Candidate is 4 and you are 5. So what I do? I decrease the count to 0. Okay, no problem. Then I come to the next iteration. I check if the count is 0. Yes, it is 0. So I change the candidate to 6 and I assign the count to 1. Then I move over here. Then I check if the count is 0. No, the count is not 0. Is candidate equal to this current element? The answer is still no. So what I will do is I will decrement the count. Okay. Then the next 3 comes. Next 3, what it will do is it will check the count is 0. So it will set it to itself and set the count to 1. And then for this 3 the count will become 2. Then this 3 the count is becoming 3. So basically if there are different elements, then obviously the count will never be having a greater value for any one of them. But in the first case I showed you that when the candidate was 4 and the count was at a point 3, and then also how much more it is, the majority element will ultimately bring this count down, and also there will be one extra majority element remaining to set the candidate as that majority element, to the value of that majority element. As soon as we reach 0, we do not change the element. In the next iteration, when we find that okay, the value of count is 0, then we change the candidate as well as the count. Cool guys, I hope this strategy is very smart strategy, and yeah, we can just code it up. This is quite easy to understand. This is a LeetCode easy. Obviously the next question is a little bit tricky, but it will be using the same intuition. So you will see that over there. There also the same intuition is over there, but it is only that a majority, that will be considered a majority element if it is present for more than floor of n by 3 times. Cool guys. So I hope this approach is clear. What I am doing is I am calculating the length first. Let me know the length of the given array, nums.length. Then what I am doing is I am taking 2 variables. First is int candidate, which is equals to 0. So I can set it anything, right? So the value of nums can be anything. So I am just assigning it with 0, for example. It will be changed as soon as it does not match, right? Or as soon as it finds out that the count is 0. Initial value of count will also be 0. After that, what do? I iterate through the array for int I equals to 0, I less than n, I plus plus, right? And what I do is first I check if the count is 0. So if count is equals to 0, then what I do? So basically there are more, so the count was 0, initially also the count can be 0, and once a value is decremented, then also a value can be 0. So as soon as a count is 0, I will set the candidate to the current element. The candidate will change to current element. It will become nums of I, and also I will set its count to 1 because it has occurred 1. Now that is it. I don't need to do anything. So I will just write a continue statement. Otherwise it will go down and check if I have just assigned nums of I to the candidate. It will again check if the current element is equal to candidate. That is something that we don't want. Now if count is not equals to 0, there is already some value, there is a candidate and its count is present. I will check if the next element that I get, if that particular element, if nums of I is equal to, is already in the candidate. In the candidate it is holding if the same value, then what I should do is I should do count plus plus. Otherwise what I should do, if the element is not equal, I will do count minus minus. As simple as that. And that's it guys. At the end of it, obviously the count variable will not store the exact count of the majority element. Okay, you can just say it by dry running on something like 3333 444. So value of 3 will basically, count of 3 will go from 1 2 3 4 to 3 2 1. After the end of the iteration, the count variable will have the value of 1. That is obviously not the number of times the majority element is present, but obviously that shows that the majority element defends its position till the end, irrespective of all the minus minus iterations, right? So obviously, and we are guaranteed to have a majority element. So I can say that whatever the after this iteration whatever the variable value is stored in candidates, that is our majority element. So we return candidates, right? Let me quickly run this. So sorry, this is candidate, right? Cool. It should be 100%. Obviously we are doing it in one complete iteration, right? So it beats almost 100%. Thank you.